Alright, let's move on to something a bit more complex. What we're going to do is I have plugged into my Bobot, below the Bobot breadboard, 2 resistors and 2 LEDs. These are going to be powered by different output pins. Now, if you're looking down at your breadboard, you'll see a P1 at the bottom and P15 at the top. This corresponds to different parts of your chip. What you're essentially doing in code, much like you would think complex with complex languages, is you're telling it where to send the power at. And there's little switches and little voltage areas that you're going to say, I want power sent to this pin for this long, or this type of power sent to this pin this long. Now, I mean, in theory, you could write some straight up assembly that does this, but with this, the IDE, it kind of gives you a little better shortcut to that, a bit more better readability. First thing we're going to do is we're going to tell the Bobot chip to send a high command to output 13. This is where I have one of my LEDs on. I'm going to have it send a low command to 12. That's where the second one's at. What this is going to do is the LED on 13 will basically light up. The one on 12 will turn off. Have it pause for 500 milliseconds. You might understand 1 hertz is equal to 1 millisecond with my particular board. Then we're going to have it flip the state. So high will go to 12, the low will go to 13, and we'll pause again for 500 milliseconds. Essentially, what this will do is we'll blink these 2 lights opposite. One will be on, one will be off, then it'll flip-flop twice for an increment of up to 4. So you'll see our LEDs flip back on and off. Save it, run it, and let's see what happens. Awesome. So we saw our little Bobot flicker. Wheels weren't moving, anything else wasn't really happening, but we did see the LEDs turn off. It's really that simple of how you would want to interact with this. You want to have multiple LEDs light up, you can put these in sequences. You can also then string these together if you had multiple colors to send an array of patterns that could chase after each other. Let's try something a bit more. On there you might have saw my piezo little speaker on there. That happens to be set up at pin 4 and then grounded out from there. Let's see. This would be frequency out, out, pin 4. Duration is going to be for 2000 milliseconds, and the frequency is going to be 2000 as well. This is going to make a pretty highly annoying noise. Let's see what happens just audibly when we run this. Hits a loop. Hits a loop again. Oh, wasn't that wonderfully annoying? Now, as with my other code there, so we'll have this LEDs blinking back and forth and making this pretty obnoxious noise. Depending on how crafty you are, I've seen some code out there that plays, say, the Imperial March in a piezo speaker. It's not the best, but, highly entertaining. Let's try one last line. I will add in, just to see kind of what the different frequency tones sound like. I'll add in one extra line. We'll send a frequency output for about 1000 milliseconds at the frequency of 1000. This should give us a little lower tone in conjunction with our high one. Save it, and let's run it and see what happens. Yeah, that's enough of that annoying noise. Alright, so we kind of have an idea of what we're doing here. Uh, the frequency voltages, where it shoots across the breadboard in a horizontal line, lights up that whole output rail. You make sure you ground back at the top, and then some basic commands. So that's pretty quick. From what I've gotten so far, this is how you would interact with this. Um, Nothing too overly complex. So far, pretty straightforward. But it's these basic building blocks that help you build a more complex program in your robot to make it do some more fun things.